As we mentioned in the last video, you can preserve the geometry when requesting data using get ACS or get decennial. In this video, we'll also learn more ways of visualizing spatial data in R. First, let's add the geometry argument to the data request here. You see I'm using the white output option here to get each value in its own column. I'm also going to use mutate to create those percentage and margin of error here. I'm just going to copy these. Wow, but the names will be different. That way we should get all 6 columns at once, right? Not only we have all 6 columns with data, we also have a geometry column, and you see the data set is simple feature collection with multi-polygon. Now we have learned before how to use plot to map spatial features. I can do the same here. Like I can map the percentage of Hispanic population that we just created. Alright, but you see plot doesn't allow a lot of mapping features, customization. It's just a very simple map. But we can use ggplot to create a much nicer map with a lot more options. Now let's see how to do that. We've learned before how to use ggplot to make graphs. It can also be used to map spatial features. And remember, we need a data argument, and then we need mapping static argument. Okay, use the pipe again here. Use the plot sign to add layers. And for simple features, you use geom_sf. And if we don't include anything here, it's just going to be a map of the census tract boundaries. But if we add the static here, fill is what set the fill color. And if you use color, that will actually set the outline color. So let's see how to change the color setting so it's more intuitive. Say we probably want to use darker colors to represent higher concentration of Hispanic population. I can use, because the variable we're mapping is a continuous variable, I can use scale fill gradient to set the color. And here I can set a low color, set it to white. Alright, now we have white color representing the lowest value of percentage Hispanic, and blue, which seems more like purple here, representing the highest value. You can also test other colors. Alright, I'm trying to find something you like. If you use scale fill gradient tool, you can also set a middle color and a midpoint. If you want to show like 2 ends of distribution and you want to set the middle color as neutral, then you can use that. You can find more examples on the ggplot2 cheat sheet. Now our variable is still displayed as a continuous variable, and most of the census tracts are yellow. What if we want to display it in several categories? What's typically done in like ArcGIS? We'll have to create a categorical variable. This can be done using pipes in the same step here. So without having to change the original dataset, we can create a temporary categorical variable for mapping. Now remember how we used the function cut to create a categorical variable out of continuous variable? So let's create category. Remember you have to set the breaks. It should be a vector of cutoff values starting from the lowest value. Let's say we want equal interval. Make sure you include both ends. Also giving them labels. So by default, remember the intervals using cut are close on the right and open on the left. And I'm setting include lowest to true. So on the very left, this first value 0 will be included. Otherwise, because the intervals are open on the left, they will not be included. Okay, make sure you match every pair of parentheses. There's another pipe here. Alright, here we have to change this static variable to the new categorical variable, and because this is categorical, no longer a continuous variable, so we can't use scale fill reading anymore, but we can use Alright, now we see the new map is created based on these categories, or 5 categories, and the missing value. The default palette for discrete colors is blues, which works here, but you can also set your own color palette in the scale fill brewer. You can set it to, instead of blues, let's say I want oranges. Okay, did that look better? There are also some palettes made of 2 or more colors. Like you can use green, blue, or red, purple. You can search online to find more options about the color settings. I can also set a name here for the legend. That looks more intuitive. We can then use chord SF to set the spatial reference for the map. By default, I use the spatial reference of the first layer, which is our only layer, census tracts. And we can also check what's the spatial reference of our POP 18. Right, my bad. We should have loaded the library SF before. Okay, now we can see Coordinate Reference System, or CRS, for this dataset is the Geographical Coordinate System North American Datum 1983. And the PSG code for that is 4269. Okay, so that sets spatial reference for the whole map. There are a lot more we can do to customize this map, and I encourage you to use the cheat sheet and online resources to explore the sliding options of ggplot. Here I'm just gonna remove the background, which is the light background around here, and remove these axis labels and marks because we don't really need those. Let's see how to show more than one layer in the map. Let's first also get the city boundaries using the place geography. Go back to this part, get data. So I guess I can copy this. And I want here is just the geography. I'm gonna call it city. And note that the place in Census is not always a city, but here for our purpose for city of Chambly, it is the same boundary. You can keep all that. The place in Census is not divided by county. I'll try with. Right, so we have all the places in Georgia. Filter to find the city of Chambly. Now we can use the same function here to check the CRS or the coordinate reference system of the city dataset, which is the same spatial reference, but we can use ST transform to project it to remember the state plane for Georgia West that we used before, which has the PSG code 2240, and we're going to transform the city dataset. Alright, now if you run this again, you see the spatial reference has changed. Okay, to Georgia West state plane. Now let's see how to display both census tracts and the city boundaries in the same ggplot. So what we need to do here is to add another GLSF, which use city as the dataset. You see here, I'm using the dataset pop18 for the whole ggplot, but it doesn't matter. I can use a different dataset for each of the layers. Alright, now the problem here is because we got the place geometry for the whole Georgia, and that's a lot bigger than DeKalb County. So when we place the two layers together, it totally make the census tracts so small we can't see them anymore. But luckily we can set the limit or display extent or the zoom level. For maps, that's basically zoom level in this court SF. So for now, let's get those axis texts back so we can see the latitude and longitudes. Okay, we know that Atlanta is around here and DeKalb County is probably in the same spot, so it's about 84 and between 33.5 and 34. So we can set X limit to, and using C to combine the lower bound and the higher bound. These are west here, so we have to use negative values for longitudes. Okay, now we do have a more zoomed in map, not exactly centered, but we do see DeKalb County more clearly now. A problem here we noticed is some parts of the census tracts, because census tracts are showing information we need in this map, percentage Hispanic, but some census tracts are covered by the city or place geometry. So we have to change that. We can either change transparency, but because we do need to keep the boundaries, so let's just set the fill back here. This is the layer with the city. Set fill to NA. Alright, now the polygon is becoming transparent in fill, no fill color. That works, but we also don't see the outline anymore. So remember, we use color to set the outline color. So let's set color to something more cool. That works. Maybe we can zoom in a little more. Knowing that city of Chambly is around here, we don't even have to show the whole DeKalb County, so you can zoom in even further. We can also set the line width here. Alright, you can try these different options to improve your contrast. But since we're only interested in the city of Chambly and its nearby neighborhoods, we want to further emphasize the city of Chambly on this map. Let's first create a dataset with only one feature, it's the city limits of Chambly. We can do that using filter. Let's create a new data object called Chambly. Let's show the head of city again. So there is a name column containing the names, including the state names of the places, and we're basically looking for the string Chambly from this column. And for that, we need to use a new function here, grepl, which will return a logical vector, true or false, if each element in the vector contains the string or the pattern we're looking for. The pattern that we're looking for here is Chambly, and the vector we're looking for Chambly from is the name column. Alright, and I see Chambly has only one observation, and that's Chambly City. Now let's add this as another layer to our ggplot. Okay, set data equal to Chambly here. And similarly, we want to remove the fill and set a different outline color. Different. Make sure you have a plus sign between any two layers. Alright, let me see where our city is. It still looks very small, so you can keep adjusting your zoom. Alright, now we can see, you already saw the bigger picture. The whole DeKalb County, most of the census tracts have very low Hispanic population, but the city of Chambly and some of its nearby neighborhoods obviously have a significant Hispanic community. Now I'm gonna remove the excess text again. Also gonna add a label for the limits of Chambly. A label using the name, just this column here. If you don't like it, if you just want to use Chambly or city of Chambly, you can change this value and this label will change as well. but here it blocks a lot of the information that we want to see. So I want to use the nudge X and nudge Y. It allows you to adjust the horizontal and vertical position of the label. Let's just move it up a little bit. Alright, maybe that's a little too far, so you can keep adjusting it until you're satisfied. Alright, so this is a way of putting different layers together and to show both our study area and the nearby areas to compare the city of Chambly with other communities around it. But what if we just want to focus only on the city of Chambly? I can use ST-join to select only the census tract that intersect or are within the city boundaries. Remember, we used left join before for joining based on common columns. But if we want to join based on geometry, we have to use ST-join. So let's say we're joining city of Chambly and pop 18, which is census tract layer. And by default, it should be a left join. But if we run this now, now note that I'm not assigning it to any new data object, but I'm just gonna run it and get an error because the two SF objects now have different spatial reference. Remember, we used this ST transform before to project the city dataset, which Chambly was a part of. So we have to do something like give it the same projection. This is bad practice. Now remember, before we want to do a left join because we want to keep only the census tract that intersect city of Chambly, but now because we're using the pipe to pass pop 18 into ST-join as the first argument. So if we do a left join, it will be including all the census tracts in DeKalb County. So we have to set left to false to do a right join. Okay, let's see. It's just printed to screen, so it might be hard to tell, but now it has 18 features, and we know the whole census tract dataset has 145 features. That means we selected only a subset of the census tracts. And if we continue to cause it to plot, okay, that's roughly the shape of the city of Chambly, but including some, if you go back to this map, you see some census tracts only partly within the city boundaries. So when you use intersect, which is the default joining method of ST-join, it's gonna include some census tracts that are not completely within the city boundaries. So what if we want to exactly cut the census tract map to the city boundaries? You have to use ST intersection. So instead of ST-join, use intersection here. Okay, that creates a census tract map that's cut to the city boundaries. But keep in mind that by doing this, you're kind of clipping some census tracts, and the population counts, the percentages, or any other variables based on census tracts may no longer be valid if you do this.